What's crackin'? I'm Shane, and hopefully you're here to see what kind of technical audio tomfoolery I've been up to lately, because that's exactly what you're gonna get. To start, I'll give you a quick tour of SpeakEasy, a tool I'm making in C# to facilitate the writing and playback of dialogue in Unity. SpeakEasy lets you create node-based dialogue trees in an editor window. When you save a tree, its data is copied into a set of scriptable objects, which can then be referenced at runtime by the main dialogue runtime script. Just a few examples of different nodes include multiple choice nodes, which offer the player choices in the conversation, logic nodes, which query a value in the blackboards of stored data and choose a path based on that query, and of course, speech nodes, which contain the dialogue text information. SpeakEasy uses Unity's API called GraphView, which is currently experimental and thus has very little documentation. But if you want to go more in depth into the code I wrote for it, you can delve into the repository I have in the description. The tool is still evolving since I'm building it around the indie game I'm developing called Office. SpeakEasy's made it simple to manage dialogue implementation in the game. It only requires that I keep track of all the unique asset names, which I do in Google Sheets. But I still had ideas for more complicated uses of sound, which is why I chose to implement using Wise. Here's a few things I've done in my game using Wise. In a street scene, I wanted to introduce a Doppler effect, so I made a script that calculates a scientifically accurate multiplier, which is sent to Wise via RTPC. That RTPC then controls the pitch of the individual car sound. I made an artistic choice to not record dialogue for the player, so my player's dialogue audio is a random container made up of 30 or so unique recorded syllables. When set to repeat and played back at the right tempo, I think it sounds pretty neat. I also created a quasi-randomized bathroom audio experience by chaining multiple random containers together in a sequence container. So every half minute or so, you get a unique visitor in the bathroom with variations in footsteps, door sounds, hand washing, and other bathroom activities. I've also begun the construction of a rhythm minigame by taking advantage of Wise's callback feature. I can send words to Unity as custom tags placed one bar before the moment of action, and the callback generates a word based on that tag and throws it towards the rectangle. That one's a work in progress. Shifting gears a bit, I'd love to share with you some behind the scenes of a performance piece I did in 2022 that made use of visual scripting via Max MSP. It had everything. 5 separate accelerometers soldered to an Arduino, which streamed motion data to the Max patch, a live audio input connected to a granular synth that samples the most recent few seconds of recording, and multiple pre-recorded samples that can be loaded into various spots in the patch. Why did I need accelerometers? Well, for the performance, I strapped those accelerometers to my various appendages and used their motion data to control different parameters in the patch. Sensors on my feet controlled the playback volume of whichever 2 samples were loaded in. Sensors on my hands controlled different values in the granular synth, like samples per second or sample length. And the sensor on my head controlled the pitch and pan of different audio streams. All this to say, I have some visual scripting experience, and if you really want me to learn Unreal blueprints for you, I will. Also, I can solder. The last example of my work I want to share with you is audio implementation in a 3D environment. Medium is an audio playground that I developed as a personal project. The gist is that there's 4 unique environments, each with their own state in Wise, which can be faded between when you enter a different one. Each environment has its own beds, ambient emitters, and these speakers that play diatonic music. I modeled them all by myself, can you tell? They were attenuated by position and orientation to create a perfect zone for listening in the center. I made use of different RTPCs to make the environment a bit more interactive, like the wind that grows in intensity the higher up the mountain you go, or the cave that gets creepier as you go deeper. Oh yeah, the cave, which I modeled all by myself, by the way. I don't know if you can tell. I don't know if this counts as an audio door or not, but I fashioned a cave entrance out of reverb zones, states, and an RTPC. The state change in audio is begun by a trigger at the entrance, and the RTPC value is derived from your distance from the entrance along one axis. As you walk deeper into the cave along the axis, the outdoor ambience fades, and a low-pass filter is applied, and cave noise and reverb rises until you hit a second trigger where you have officially entered the cave state. Oh gee, that was a lot to throw at you, but I'm glad you decided to stick around until the end. Hopefully you saw some cool technical audio stuff, and I'll see you around in the game audio world. Thanks for listening.